Hello online viewers, welcome to our lecture video. In this lecture video, we'll be talking about conditional probability. What is conditional probability? How we can mathematically define conditional probability, and what is the formula behind calculating conditional probability. But before going into conditional probability, I would like to request all of you to check my previous video on probability, so you can have a clearer concept of all the technical terms we'll be talking in this lecture video. So now, firstly, let me simply define what is conditional probability. Let A and B be any two events defined on sample space omega. Then the conditional probability of event A is defined as the probability of occurrence of A when it is known that B has already occurred and is denoted by P A slash B. You may not have got any idea of what is conditional probability from this definition, but let me show you. Let me give you a example, and let me give you a brief description. So let's say, so as we mentioned over here, the symbol or the symbol or the denotation of conditional probability is P A slash B. So if I just write PA, we know that PA means probability of occurrence. It simply means the probability of occurrence of event A. Probability of occurrence of event A. But let's say if I had to calculate the probability of occurrence of event A, or if I had to calculate this same probability but under some circumstances or under some conditions. Under some conditions. So simply calculating the same probability but under some conditions and under some circumstances is called as conditional probability. So is called as conditional probability, and it is simply written as P A slash B, and this slash is written as and this slash is read as given that, and all this is as a whole is written as, and all this as a whole is read as probability of occurrence of event A, provided or given that the event B has already occurred. So it means so it simply means probability of occurrence of event A, given that event B has already occurred, as event B has already occurred at first. So this is simply conditional probability. We are simply calculating the occurrence of event A, but for that event B has already occurred at but for this event B has already occurred at first. Occurred at first. So this is our idea or logic behind conditional probability. So the logic behind conditional probability is that we are calculating the probability of occurrence of certain event, but before that certain event, another event or the conditional event has already occurred at first. Now for a simple now to tell a simple trick about conditional probability, let's see conditional probability. What happens in conditional probability is before this sign over here, we'll write an event. In this over here, at first we'll write an event whose probability is to be calculated, or we can simply say the in first over here, we'll write a second event, which occurs after completion of some conditions, and this is going to be our first event. Or simply our conditional event. So in our conditional probability, this event will occur at first, and this event will occur at first, and this event will occur at 7, and simply will be calculating the probability of occurrence of this event after this conditional event has occurred. So that's our logic behind conditional probability. Now I've already described this portion. Now for the mathematical definition, it is defined as the fraction number of simultaneous occurrence of both events A and B to the occurrence of known event B. So simply the conditional probability is defined as is mathematically defined as an A intersection B divided by n B, and A intersection B divided by n B. So from our mathematical definition also we get the same logic or the same idea. Probability of so for our conditional probability, firstly the event B has to be firstly the event B has to occur, and after event B has occurred, both events A and B has to occur. So simply the ratio of occurrence of both events A and B to simply the occurrence of event B will give us our formula for conditional probability. Next we'll be talking of our nodes for conditional probability. So for our first node we have P A slash B, or probability of occurrence of event A given that event B has already occurred at first is given as probability of occurrence of both probability of occurrence of event A and B divided by probability of occurrence of event B. This is simply this is simply calculated. This can be simply derived as if we simply divide by n omega, or by sample space, we simply get this formula. We simply get this formula. This is how this is derived from here to here. Next is we're talking about probability of occurrence of event A when outcome or when event B has already occurred at first. But if we have to calculate conditional probability of occurrence of event B when outcome of event A is known, then we denote it as P B slash A. So as I explained before, we're calculating the probability of occurrence of event B. So B is written at first and the conditional event is A. When outcome of A is known, or first the outcome of A or first the event A has to occur, so it is written as second. And it is denoted as P B slash A, and it is given by P B slash A equals to P A intersection B divided by P A. Same thing, but same thing and to remember this formula, whatever comes in second goes down. Now for our third node, if two events A and B are independent, then P A slash B equals to P A, and P B slash B, and P B slash A equals to P B. And now for the proof of this person, P A slash B equals to P A union B divided by P from node 1, and P A union B and P A intersection B, and P A intersection B equals to P A into P B. So since we learned from our previous video, for independent events, P A intersection B equals to P A intersection B equals to P A into P B. Now we simply add P A into P B divided by P B. P B and P B gets cancelled out. So P A slash B for independent events is simply equals to P A. Now we'll be solving a problem related with conditional probability. Now our question reads: a group of 100 persons, 70 are graduate, 40 are employed, and 20 are both. A person is selected randomly. If it is known from some source that the selected person is employed, then find the probability of him or her being a graduate. So the question might seem a bit confusing, but what the question is simply asking us is, it is asking us to find the probability of him or her being a graduate, but the condition is that selected person is employed. If it is known from some source that the selected person is employed, then find the probability of him or her being a graduate. So firstly, before telling what comes over here and what comes over here and what comes over here over next after this bar, I have drawn a Venn diagram to show here A denotes graduate, which is 70, and B denotes employed, which is 40, and the intersection, which means being both graduate and employed, are 20. So we have written 20 over here. So let me begin this. So simply let me begin the solution portion first. Solution: let A be event. So let A be event that the selected person is graduate. So as you can see here, we have two events over here. First is graduate and second is employed. So we'll be denoting them both by capital letters A and B. Let A be event that the selected person is graduate. B be event that the selected person is employed. B be the event that the selected person is employed. Then what we have over here is an A equals to 70, as our question says, comma, and B selected person is employed is and B equals to 40, and 20 are both. So an A intersection B equals to 20. Now what we have here is n omega, total number of sample spaces 100%, so group of 100%, so n omega equals to 100. So now first let me write the probability of selecting probability. Now first let me find PA, which means probability that the selected person is graduate, which equals to NA divided by n omega, which is equal to 70 divided by 100, which is 7 by 10. Similarly, let me calculate which means that the probability that the selected person is employed. So this is equal to NB divided by n omega, which is equal to 40 divided by 100, which means 2 by 5. Which means 2 by 5. And now PA intersection B equals to same NA intersection B divided by n omega, which I get to be 20 divided by 100, which is 1 by 5. Now let me move on to what question is asking to me. A person is selected randomly if it is known from some source that a selected person is employed. Which means this is our condition. Then find the probability of him or her being a graduate. So in my previous part of the video, so in this first portion, in this first event is the this event, the event which comes at first is the event whose probability is to be calculated, is to be found, or is to be calculated. So this is quite so this can get quite confusing sometimes, which event comes before the bar or which event comes after the bar. So simply the first event is the event whose probability is to be calculated. So find the probability of him or her being a graduate. So being graduate is denoted by A. So let me write A over here. So simply now if it is known from some source that a selected person is employed, which means this event has to occur at first, or if it is known from some source that the selected person is employed, which means that this event being employed is our conditional probability, or this event has to occur at first, then this event will occur. So the event that the selected person is employed is denoted by B. It's noted by B, and this comes over here. This is our first event which has to occur, or this has so this is our first event which has to occur at first, or this is simply our conditional. This is simply our condition. So this is simply our condition to occur before occurrence of A. Now we'll write probability of him or her being graduate known that him or her is employed is denoted as P, probability of him or her being graduate. So I am explaining again. So in this first portion, the event comes whose probability is to be calculated. So we are calculating the probability of being graduate, denoted by A. So this comes over here. Second comes our conditional probability which occurs at first, which is being employed, denoted by B. This is equals to from our formula what we have is PA/B equals to P A union B divided by PB. So this is simply PA/B equals to P A union B divided by PB. We don't need to remember the formula. The formula is simply for two events A and B. This is P A intersection B divided by this. Whatever is the second event, this comes down over here. So to remember the formula, P is 1 by 5 divided by PB is 2 by 5. So we simply get 1 by 2 on solving. So this is how you solve the problem of conditional probability. Hope this video was of help to you. If you have any queries, you can comment down below, and you can find it in our Instagram page, whose link you can find in the description box below. Thank you.